Hey guys, today we are going through the next part of the Alleyn School Maths sample paper. So let's get straight into these solutions. Okay, so now for this next question, we have to work out the hours and minutes between 9:34 in the morning and 1:21 in the afternoon. And the way to do this is to take it step by step. You don't want to treat this like normal numbers and try and subtract them in a column. That's not going to work, right? We don't want to do this. Instead, we want to take it very methodically when we're working with clock times and simply go to the hour and then work out the number of hours and then simply go to the minute. So let's break down what I mean there. So if we're starting at 9:34, then let's first get to 10 a.m. And we do this by adding on how many minutes? Well, it's going to be 26 minutes, right? The 6 gets us to 40, and then the 20 gets us to the hour, 60 minutes in an hour. So plus 26 minutes. Then we're going from 10 a.m. and we're going all the way to 1 p.m. or 1300, right? How many hours is this? This is going to be 3 hours. And then we're going from 1300 to 1321. And this is going to be 21 minutes. So you're seeing we're taking it step by step. So now we have 3 hours plus 26 minutes plus 21 minutes. And that should give us 3 hours and 47 minutes, because 26 plus 21 is 47. So that's our answer, and we can see that's also an option. Option B, 3 hours, 47 minutes. That's how we work out these clock difference questions. Okay, so here we're simply going to draw upon what we were talking about in previous questions about the different columns past the decimal point. Remember, we were talking about the tenths column and the hundredths column, thousandths column, so on and so forth. That's all the knowledge we need to answer this question. What is the value of the digit 9 in the number 32.597? Well, here, this 32, the 3 is a 10. And then the 2 is a unit. Then we have the decimal point. The 5 is in the tenths column. The 9 is in the hundredths column. 7 is in the thousandths column. So we care about the 9. Let's make it red. So this 9 is in the hundredths column. And because it's in the hundredths column, it represents 9 hundredths. So the answer is D. Okay, so here for this next question, to work it out, there are a few steps we have to go through. So let's go through each of those steps one by one. I buy a pen and a pencil for £1.10. The pen costs 50p more than the pencil. How much is the pen? Okay, so here we need to write out some equations. And effectively, we need to turn this question, we need to turn these sentences, these words, into maths. So how can we do this? Well, for the first sentence, I buy a pen and a pencil for £1.10. What does that mean? That means pen plus pencil equals 110p, or just 110. We've converted that £1.10 from pounds to pence. But then we have a second equation. And do we know the second equation? Is there a second equation? Let's try and find it. The pen costs 50p more than the pencil. What's the equation, or what's the maths in that sentence? Well, the pen costs 50p more than the pencil. So whatever the pencil costs, the pen has to cost 50p more. Whatever the pencil costs, the pen has to cost 50p more. So that means the pen equals the pencil, like we just said, plus 50p or plus 50. This is some more advanced maths, but now we can use substitution. And that simply means understand that we have pen here and we also have pen here. So we can substitute what we know about pen here and chuck it over here. And doing this will help us to understand what the pencil is. So let's do it for real so we can see what's going on here. We know that pen plus pencil is 110. But we also know that pen is pencil plus 50. So if we know these two things, we can substitute pen for pencil plus 50. That's all substitution is. So now we have pencil plus 50 plus the rest of this equation. Pencil equals 110. Now pencil plus pencil is 2 pencil. So we'll bring it up here. 2 pencil plus 50 equals 110. Then we can work out what pencil is. First, we can minus 50 from both sides of the equation. Remember, whatever we do to one side, we do to the other side. So now we have 2 pencil equals 110 minus 50, which is 60. So pencil, divide both sides by 2 is 30. Okay, let's clean up this board. We've got some really useful information there. Pencil is 30. This can help us because we know that the pen right here is pencil plus 50. So if pencil is 30, then pen is simply 30 plus 50. So pen has to be 80p, which is D. So D is our answer. And that's definitely one of the harder, more advanced questions. But once you understand the concepts that underpin it, you can get it right every single time. Our answer is D. Okay, so here for this next question, we have some simple questions, but we have to make sure we make no silly mistakes. First, we have 454 plus 297. So let's work that out, remembering to show our working as the question asks us to. Plus 297. Well, we could use column addition and work it out this way. So 4 plus 7 gives us 11. So 1, carry the 10. Then 1 plus 5 plus 9, well, that's 6. Plus the 9 is 15. So 5, carry the 1 over. Then 1 plus 4 plus 2. So 5, 2, 7. 7, 5, 1. Right? Or we could use mental maths. And maybe we don't use mental maths to answer the question because they want to see working. But we can use mental maths to check our answer, to see if we made any silly mistakes. And how would we use mental maths here? Well, we would realize that 297 is very close to 300. It's only 3 off 300. So what we can do is we can simply, in our head, do 454 plus 300, which is 754. And then we minus the 3, giving us 751, which is indeed our answer. So understanding and building your mental maths is so useful for your 11 plus exam. When we can do this efficiently, it helps us to check our work and also helps us to get answers right in a fraction of the time of doing longer, more drawn out methods many times. So here we have 604 minus 447. Here, let's do the actual column subtraction. First, we have 4 minus 7. We can't do that. So we take a 10 from here. We can't do that. So we take a 10 from here instead. This goes from 6 to 5. This becomes 10 or 9 now. And this becomes 14. So now we have 14 minus 7, which we can do because 14 is bigger than 7. And this gives us 7. Then we have 9 minus 4. which is 5. Then we have 5 minus 4, which is 1. So 157. Okay, so now we have 32 times 74. So let's work this out. 32, 74, we have 2 times 4, which is 8. 3 times 4, which is 12, so 2 carry the 1. 7 times 2, which is 14. Add the 1 is 15. And then we have 3 times 7, which is 21. Add the 1 is 22. So now we have 8, 7, 2, 2, 2,278. And then here we have 4, 1, 8, 4 divided by 8. Well, 8 into 4 we can't do, so 8 into 40, we have 5, right? Because 5 times 8 is 40. And then we have a 1 left over. So now we bring down the next number, which is the 8, and we have 8 into 18. Well, that's going to be 2, right? Because 8 times 2 is 16. And we have 2 left over, bring down the 4. And then we have 8 into 24, which is 3. 8, 16, 24. Really helpful if we know our times tables just like that. So 3. So here we have no remainders. Our answer is 5, 2, 3. Okay, so now let's go through each of these parts, part A, B, C, D, one by one, and let's work these out. So first for part A, we have 5 ninths plus 2 ninths, 5 over 9 plus 2 over 9. Here they've made our life pretty easy because we already have a common denominator, right? We have the numerator up top, denominator at the bottom. Because both denominators are the same, we call this a common denominator. And therefore, all we have to do to work this out is add across the numerators. So 5 plus 2, 7 over 9. The denominator stays the same. So 7 over 9 is our answer. Pretty simple, pretty quick. Then we have part B, 3/4 plus 1 over 8. So here we don't have a common denominator. So we need to create a common denominator. And we're going to do this by multiplying both the numerator and denominator of this left fraction, do that a bit better, by 2. When we do this, what happens? Well, we have 6 on top, numerator. Then what do we have on the bottom? 8, which is really useful because now we have 6 over 8 plus 1 over 8, common denominator. We can add across the numerators, 7 over 8. Then we have 5 over 6 minus 1 over 2. Same concept. We're searching for the common denominator. Here we multiply by 3. So it's going to be 5 over 6 minus 3 over 6, giving us 2 over 6, or 1 over 3 when we simplify. And finally for D, we have 7 minus 3 over 7. Now here the trick is understanding that 7, yes, it's a whole number, but it's the exact same thing as 7 over 1. Any number is the same as that number over 1. We could have a million, and a million is still the same thing as a million over 1. So let's rub this out. If we have 7 over 1 minus 3 over 7, we do the same thing, common denominator. Multiply this left fraction, top and bottom, numerator and denominator by 7, giving us 7 times 7 on the top, times tables, 49, over 7, minus 3 over 7. Subtract across the numerators, denominator stays the same. We have 46 over 7. And this is an improper fraction where the numerator is greater than the denominator. But we can also turn this into a mixed number in case the question asks for it, or maybe you worked it out as a mixed number. How can we do this? Well, we simply take this division, 46, divided by 7, and we try and replicate it. So here, if we work this out, how many 7s go into 46? Well, if you know your times tables, you know 7 times 7 is 49, which means it has to be 6, because 7 times 6 is 42. And we have a remainder, therefore, of 46 minus 42 of 4, right? So let's break down what does this mean. It's telling us that 7 goes into 46 6 times, remainder 4. And therefore our mixed number is 6, because it goes into 46 6 whole times. And the fraction part of this mixed number would be 4 over 7. The remainder over the divisor. 6 and 4/7. Whole part, fraction part. So the answer is 46 over 7, improper fraction, or 6 and 4/7, mixed number. Both answers are correct. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.